Just to let you know a little bit about myself, my name is Dave Emmons. I'm the technical training manager at this point in time for everything east of the Mississippi River. My partner in crime, Mark Saunders, is the training manager for everything west of the Mississippi as well. And we kind of share Canada and Latin America together as a team. So just to give you some background on what we do here. If you have any questions during the presentation, feel free to ask those via the chat feature. I will try to answer those during the presentation if I can. If not, I'll wait till the end to address those there. The material should only be about 20-25 minutes in length before we get to Q&A. So feel free to ask questions as we go along to keep things a little more interesting. Now, today's topic is really a high-level discussion of the regeneration process that takes place in a water softener, anyone's water softener. It goes through the same steps. The valve itself, whether it is a flex valve or an auto-troll valve, it really acts as a traffic cop directing water and flow. But what's really responsible for all the magic, the chemistry that's taking place inside a water softener is the water itself and the pressure and flow going through the tank and its contact with a chemical media known as resin. Whether that is resin or anion resin, the principles all apply. So we're going to talk about each step because as a troubleshooter, if we want to understand where our problems lie, we have to understand the steps in the process and what should be happening in that step so we can understand why we are having failures so we can correct them. Without understanding the base steps in the process, we get confused. And we see that a lot, in technical support, people calling in just not really understanding what the device is doing. So the better we understand the device and its steps, the easier it is to troubleshoot and get a satisfactory result for everyone involved. So we'll go ahead and get into the first step. We're going to talk about downflow brining followed by upflow brining. And I don't necessarily have a preference for either one. The conversation upflow versus downflow brining, if you walked into a room full of water treatment professionals, it's probably a good topic to start a heated debate, okay? From a chemistry perspective, because I'm a chemist by education, I see benefits and strengths and weaknesses in both processes. It's like anything else. If you do it well, you will perform well. If you do it incorrectly, you'll get less than satisfactory results. So if you're going to pick one, make sure you understand which you're doing. First of all, downflow brining that we're going to discuss is the most common brining path or process, regeneration process, that we see in ion exchange today. So we'll talk about that first. The first step in this process, well, let's define downflow regeneration first. So what does it mean? Downflow regeneration is also known as co-current. This means that regeneration occurs in the same path, flow path that is, of the ion exchange and service flows. That means top down in this case, from the top of the tank down. The brine enters in at the top of the tank, slowly flows through and over the media, pushing off the hardness minerals and replacing them with sodium. It's the opposite of the softening process. This flow path of downflow regeneration determines the order of the steps, what we must do first. So the first step is backwashing. And to quote an OEM of resins in the marketplace, this is critical to the life of the resin and the performance of the resin in the tank. And it's the most important step. Why would a resin manufacturer stress backwashing? Well, what happens during backwashing? We reverse the flow through the softener. The piston moves in, or the flappers move inside the valve, reversing flow and opening a waste line. So the water is going to go down through the resin and up through the standpipe. The water goes down through the center standpipe, out the distributor, up through the resin, and out to waste. And in this process, what we are doing is removing the bulk dirt off the unit. Why? Because every media, every packed column you have, and that's all what a resin tank is a packed column of beads, whether that is resin, sand, activated carbon, whatever media you put in there, it acts as a crude filter, okay? It's gonna load up with dirt. And on top of it, if there's any non-polar stuff in there, like other parts of the resin bead, it's gonna attract organics to stick to it. And that's gonna happen in the upper third of the bed, okay? So what we're gonna do is reverse the flow, but we're gonna expand that bed. And we wanna see, based on resin manufacturer specifications, okay? Whenever dealing with a resin, you wanna check the OEM spec sheet so you know what you're dealing with. Get the facts, don't just apply rules of thumb. You're gonna expand the bed 50 to 75%. And what this does for us, it loosens up all that debris, breaks up the potential filter cake on top of the resin, flushes that dirt off. And then, in this process, if you can picture a bingo ball machine or a lotto machine where you're seeing all the balls tumble around, that's what's going on here. And when those balls collide, they scrub each other clean, okay? Not 100% clean, but clean. And they're going to take any bits and pieces of that broken beads and resin from time in the tank are going to get washed away as well. And what this does is it stirs everything up and allows some more space for good contact with brine. And minimally, we want to see 2 bed volumes of water go through a tank, regardless of its size or media, to do a good backwash. The media itself determines the rate at which you have to backwash, okay? The weight, the physical density, the weight of that material in the tank will determine the rate you have to backwash at. We're talking about regeneration softening right now, but that's true for any media. Get that data from their spec sheet. So we want to see at least 2 bed volumes of water go through the tank. 3 or 4 is better. For a cubic foot, our units come pre-programmed at 10 minutes with an average, drain line flow control sizing. This should give you on a cubic foot tank a minimum of 2 bed volume, most likely 3 or 4 if you're dealing with average situations. But this is a good thing to do, because what it does is allows us to reclassify the resin bed, uncompress it, get it ready for what we're about to do with it from a chemical perspective with brining. And one thing about backwash, the warmer the water, the longer the backwash you need. The dirtier the water, the longer the backwash, okay? Everything in water treatment is a contextual discussion. It's all about the water you're putting it in, that source water that you're dealing with. That's what you have to be concerned about. When you hit around 80 degrees incoming water temperature, and this does happen in the southern United States quite often, and definitely in Latin and Central America, you need to extend your backwash times to get that. Why? Because the water isn't as dense. You think about, when things get cold, they shrink. Things get warm, they loosen up. Well, when you loosen up the water, when you warm it up, it doesn't have the ability to lift that resin as easily. Okay? So we need to extend that backwash so we can get it clean. And if we don't backwash properly, what happens is we start to coat the resin further and further down the tank with debris, and eventually it will start to push through and come out to surface. And then you're left in a situation where you have to do an immense amount of cleanup or exchange the resin for something that's nothing more than dirt load. There's probably nothing wrong with the resin at that point in time. It's just so filthy that you really can't use it anymore. So a good backwash, adjusting this, make sure you get a good backwash in your system. I've had to increase the backwash in my own system at home simply because my water treatment plant changed its process a little bit to save money, and I have more particulate in my water now. So I have to make sure I get a good backwash. Now, the second step in the process is brine draw and slow rinse. And the reason we lump these together, because the piston in the valve only moves once here. Okay, it's changing the path. And what's going on here is we're switching from the reverse flow through the tank on the backwash to a normal flow through the tank. But instead of using full flow water flow, we're pushing all the water through the brine valve and through what's known as a venturi or an inductor or eductor, depending on the term you want to use. But essentially it's a venturi. And this creates a vacuum in the line going to the brine tank. This is the point in the process where we are mixing the saturated brine in the brine tank with incoming tap water or soft water, depending on your process, to a specific percent solution. And ideally in water softening, that's a 10% solution. Acceptable is 9 to 11%, 12%, somewhere in there. But anything outside that 12 or below 9, you're going to start to impact the regeneration, either by not being thorough enough on the low end and wasting salt on the high end. So the water runs the waste in this process. It flows around the brine line flow control being drawn up from the tank. This solution now will enter in the top of the tank, and it'll start to push that wave of tap water that's at the top of the tank down through the bed. And what you get coming out the waistline, and this is where things like elution studies take place, okay? In the first case, in backwash, we were looking at dirt coming out the waste stream at full flow, right? Well, that dirt profile coming off of that waistline, that should follow a bell curve. It should go from clear, you start to get dirtier, get real dirty at a peak, and then start to clear up, and then finally go back to tap water and clear. That's what we want to see here, is a nice bell curve on the backwash. We also want to see a nice bell curve, and in the field, the easiest way to do this is with a TDS meter. I know there's some technical issues with not using a salometer. I get that. But if you just want a quick reference of what this looks like, you're going to check TDS. It should start off as tap water, and then the TDS should start to grow as that solution starts to exchange hardness off the resin, so we should get more mineral concentration. And that should start to build into a nice bell curve. It'll peak really, really high when that final layer of brine gets to the bottom of the tank and starts to come out, and then it'll start to come back down, and it'll go back down to tap water that's softened at that point in time. This is a 60-minute process, and this is how it's been done. You can measure this with a salometer, which is a measuring tool for measuring salt density. You can also do this the old school way by tasting it. Remember, this is a waste stream. Do not drink this water. But the old school guys would just taste water every 5 minutes coming out. And it's going to go from tap water to being really bitter because calcium, magnesium, iron have a real bitter mineral taste. And then it'll start to mix back in with salty and get really, really salty. And then that saltiness will ebb back into tap water again. And that's the path you want to follow to make sure you're brining properly. And this process typically takes about 60 minutes. Now, at the point when we've drawn all the brine out of the brine tank that we can, there is an air check, either in the tank, in the case of a Fleck valve, or up in the head in the case of some of our auto troll valves. This ball will then seat and seal off whatever remaining water is in the brine tank so we don't draw air into the resin tank. Okay, at this point, we've converted over from brine draw to slow rinse. And this is where all the water's still going through the injector, but it's nothing but tap water. And it's flushing out, slowly rinsing out any built up salt or any salt that has been in excess and hasn't been pushed out of the system yet. Once that cycle is complete, we're going to switch over to the third step, rapid rinse. So at this point in time, our bed has been fluffed up, backwashed and cleaned. Our resin has been regenerated with a brine and it's been rinsed, but it's still all loose, not really ready for service. And it may still have a little bit of salt here we don't want going downstream to service, okay? So this is where rapid rinse takes place. And now you're gonna switch the position of the valve. You're gonna isolate the brine valve again. It's going to go into position where it's off, and the piston is going to move. And this is going to allow service flow, water coming in from the top of the tank down, out through the center standpipe, but to waste. At this point in time, if we see any lots of brine, it should come out in the first minute or so of this process. But what we're doing here now is we should have soft water coming out the waistline. If you do not have soft water during rapid rinse, you have a bypass in the piston. So this is where you start to bypass the, troubleshoot the internals of a water softener, is by evaluating this step, because the only thing different here between service and rapid rinse is that the water is going to waste in rapid rinse and not to service. So water is flowing at a full rate to waste, and this is compacting the bed. And this is so we can't bypass the resin. The resin settles into position. It's classifying the bed. It's all, this helps prevent channeling and hardness leakage at this point in time. And it rinses out any remaining brine. And this helps prevent salty water to service. If you are getting salty water to service, we definitely have an issue with your ability to draw brine in. So once we've rapid rinsed, and this is where you can save a little bit of time on and water during your setup process. As long as you get enough time to rinse it clean and you don't have any issues, you can shorten this cycle to where you need it to be to save a little bit of water. This is getting ready for service. We want to make sure we pack that bed down. The fourth step typically is brine fill. What we're going to do is we're now going to take some of that incoming tap water, and the brine valve is going to switch from draw to fill. And the brine line flow control is a little rubber gasket with a hole in it inside the tube, in the head of the tube typically, that goes down to the brine tank. And when the water hits this, it's going to seal and only allow the water to go through the center of the tube. And this controls the rate at which the brine tank fills. So if you have I'm using a very simple number here. If you have a 1 gallon per minute brine line flow control, it takes a minute to put a gallon of water in the tank, okay? So this is where you're going to program what you want to brine at. If you're dealing with a 1 cubic foot softener and you want to brine at 9 pounds, let's say. Well, 1 gallon of water dissolves 3 pounds of salt. That 3 pounds of salt, I want 9 pounds, so I need 3 gallons of water in the tank to dissolve 9 pounds of salt. Okay, and in a traditional brine tank situation, we don't have to worry about the additional volume created by salt. If you're dealing with a brine tower or separate source regeneration with separate source brine solutions, in this instance, that's going to be a little bit different scenario because that situation isn't controlled by the float. Okay. And really that's where we're measuring to when we're drawing brine out of a brine tank as to where the float seals off. If you're dealing with a brining situation with a brine tower or a subterranean brining system, that brine is going to be delivered by a pump. So you're going to use a solenoid to control that. And there's some different calculations you need to do there. I'm not going to go into that right now. So it takes approximately 4 hours at average temperatures and pressures to dissolve and create a fully saturated brine solution. You will get an acceptable brine solution in about 2.5 hours. But that's why we always fill at the end and let that brine sit and soak and get good and saturated so we have a good reagent to react with our resin when we go to regenerate. Some areas of the world, it may be beneficial to refill the brine at the start of the regeneration process to prevent salt bridging due to humidity and things like that. Or coastal regions where you may have bacteria that can tolerate the level of salinity in the brine tank. So they may fill that brine tank first and then wait for 2 hours before they even start the backwashing process. So now we're making the brine for the next regeneration after the unit's in service, prepping it to go. And then the final step is return to service. Valve position is going to move back into the service position, and we are delivering soft water downstream. Everything is back in business. And this process is repeated every time it regenerates. And we'll go into troubleshooting both the brine system, brine tank, and backwashing and all that sort of technical detail in other presentations later this summer. We wanted to break it up into little bite-sized chunks for you guys. So the next process is the upflow process. What does upflow regeneration mean? Well, upflow is also known as countercurrent, which means against the flow of the current. This means we're regenerating in the opposite flow pattern of service. So service is top to bottom. This is bottom up regeneration. The brine is injected through the center standpipe and flows down and out through the distributor and up through the resin. This process, because of the flow pattern, changes the order of the regeneration process. And it's critical to understand that in upflow regeneration, we don't want to disturb the bed. We want to have the regeneration process slowly go through the resin without moving it much at all. The other thing is we don't want to regenerate with hard water here either, because we want to make sure we're extracting all of the efficiency out of the tank. And the reason people select upflow brining is because in the bottom 10 to 20% of the tank that's used as a reserve capacity, typically that resin never gets regenerated, never exchanges any ions out, or very few. So what we're doing is putting that brine at the bottom of the tank, and it's going over the initial 10 to 20%. It's already got sodium all over it. There's nothing to regenerate there. But as that band moves up and it starts to regenerate, all the hardness is being pushed up and off the bed and past resin that's already saturated with hardness. So it's not going to compete with itself for regeneration. This gives you a more effective regeneration as long as you're regenerating with soft water and you are doing the rest of the process with soft water. Quite often you will see this process used on twin tank systems because you absolutely have control over the entire process using soft water for regeneration. If you don't, you're going to see some competition in the tank for exchange, and it's not going to be as efficient as you would like it to be. And in upflow, that also means we can start cutting into that reserve capacity and get more capacity out of the same tank. But if you do this too quickly, you fluff up the bed and you lose the efficiencies. So upflow brining has to be done really, really slowly, or with a kind of a weighted disc that will stay in place on top of the bed and keep it weighted down so that it doesn't fluidize the top portion of the bed and only moves during backwash, if that makes sense. But the process changes the order of steps. So the first thing we're going to do is we are going to go through brine draw. We're going to draw the brine out of the tank, and some of these systems will actually start off by putting water into the brine tank, waiting 2 hours, and then starting it. And you're going to regenerate from the bottom up, and this lightly loosens up the bed, and it will carry out some of the dirt with it as it goes to regen. Then it's going to go into brine fill and fill the brine tank back up for the next regeneration. And then it's going to go into backwash, and it's going to wash the bed. But if you're backwashing with hard water, what are you doing? You're running hard water at a surface flow rate from the bottom of the tank up, and now you have hardness on the bottom of your resin that you're going to push off immediately when you switch into service. That's why regeneration with soft water is the way to go with upflow brining. You're going to do your backwash, you're going to clean the bed, you're going to reclassify the bed, and you're going to hit rapid rinse right after that. That's going to reverse the flow, pack the bed back down, and now you're going to switch after that's done and go right into service. But you need to understand in this process what you should see from a troubleshooting standpoint, so that you understand why the softener is doing what it's doing and where a problem is. The same sort of elution studies apply to upflow brining as downflow, but it's critical to understand with upflow that you need soft water regen or separate source regeneration to extract the efficiencies out of it, but it does work. So it's just a different tool, a different way to exploit resin technologies. It's a different way to squeeze some more efficiency out of the same equipment. And it's just one of those topics that's going to start some conversations in a group of water treatment professionals. So downflow versus upflow, even our own technical staff within Pentair have very strong feelings about this topic. So feel free to discuss, be happy to go back and forth with anybody on this topic. It's a way we educate each other and learn from each other. More than happy. No preference for either one. Just want to make sure if you're going to do upflow to see the best effects from it, especially in commercial and industrial waters, process waters, do upflow the right way. In a residential situation, you're not going to see as much benefit, but you're not going to see nearly as many problems either. If you're dealing with high purity waters, upflow is a benefit, but you better make sure you do it well. Okay, that's really what it comes down to. It's like any other job a technician or service guy does or dealer. You choose the right tool, use the tool the right way, you get good results. Most of the time, poor results with upflow is a result of not applying it properly, not setting it up for success. And that's what we want you to do, is set yourself up for success. Something new this year, always like new, and it's free. That's always a great plus to anything. We've created the training.request@pentair.com email box. This is a place for dealers, distributors, internal folks at Pentair, anybody in the world who wants to request some training. You can do so here. When they free us up to travel again, this is in-person product training, troubleshooting training, water quality, basics of water treatment, opportunities around treatment training, like where to apply it, valves, controls, filter cartridges, reverse osmosis systems for residential use. If you just want to talk shop about a project, happy to set some time up to do that. And if you just want to give us feedback about a product, you want to complain, you want to compliment, you want to let us know issues you're having, awesome. This is another place for you to do that. You know, I was a technician for 20 plus years. I know what it's like to think that a big manufacturer doesn't hear you or listen to you. Well, I've been in your shoes. I'm here to listen, and I know the right people to go talk to as well. So let us know what's going on, and sometimes I may ask you to support some of your stuff with some data and things like that. But that's all an effort to get things corrected if there is an issue. So feel free to hit us up and request training. We're free for webinars right now. Any topic you want to request, whether it's product or if it's just a discussion over a process or water quality, whatever it is, we're happy to take your requests. Training when you want it, when you need it, just feel free to ask. So are there any questions? Feel free to unmute yourselves and ask a question at this time. If not, have a wonderful afternoon, and thank you for attending. Hopefully we'll see your names next week as well. So feel free to ask away. Well, it looks like we don't have any questions, so I'm going to go ahead and end the meeting. But if you do have any questions, feel free to reach out and ask us. That's what we're here to do in the training group. That's all we really do is talk treatment and water. So let us know, and we can have some fun talking about it. Thanks a lot. Have a wonderful afternoon or evening or morning, depending on where you're at in the world. And we'll chat at you soon.